Today's Daily Dose of Math is a question about a periodic function. Here we have a graph that shows a periodic function, and what that means is there's a shape on the graph which keeps on repeating. The period is the part of the graph from the beginning of the repeating pattern to its end. So the period is 5 squares on the graph paper with this one. Now this is a very simple diagram where I haven't shown an x or y axis and I haven't shown the scaling of either axis. So let's just assume that every square in the graph paper is equal to 1 unit along the x direction and 1 unit along the y direction. That means I could show my scaling like this. So the highest this function ever goes is y equals 3. And its period is 5. It starts, it describes its shape, and then when it gets to 5 on the x-axis, it starts over again. It's a pretty simple periodic function. Now let's look at some of the questions that you can get about something like this. Questions A and B are very straightforward because we're being asked, what is the value of y when x equals 9? And x equals 9 is right here. And B asks whether the function is increasing or decreasing between x equals 13 and x equals 14. I can see it well enough to answer the questions without having to do anything special. The trick to answering questions about a periodic function, though, is that they're not necessarily asking you for x values that are showing on the graph that's sitting in front of you. They may ask you about much larger x values, like in questions C and D, where x is equal to 62 or 71 or 72. That part's not showing on the graph. So how do we answer this question? There is more than one method. The first method that we will talk about in this video is by drawing the graph yourself, but drawing it bigger. So we can see that the value of y when x equals 9 is the value of y when our periodic function passes through this red line that I have added to the graph. The value of y is 1. So I have my answer. There's my answer. Now, for B, is the function increasing or decreasing between x equals 13 and x equals 14? Well, that's going to be between these two green lines that I have added to the graph. And I can see that the function is decreasing. So I have my answer. But what about questions C, D, E, and F? We have much larger values for x. So one thing that we can do is draw the graph bigger, covering a much longer interval along the x-axis. And it might look something like this. Here, we're being asked in C, what is the value of y when x equals 62? By drawing my graph much bigger, I go past the point where x is equal to 62. X is equal to 62 where I have this red line. And then I'm able to see, well, the value of y is 2 at that point. And I'm able to answer question C. And D is the function increasing or decreasing between x equals 71 and x equals 72. That's the area in between these two green lines. And I can see that the function is decreasing. So I'm able to answer my question. But then we look at questions E and F. Now the x values are even larger. And even having drawn the graph this big, covering such a wide range along the x-axis, x equals 133, 148, 149 still don't fit. But of course, I can draw the graph even larger if I wish. Now, you'll notice that it's getting harder and harder to see what we're doing, and it's getting harder and harder to fit the graph on a single sheet of paper so that we can answer in this way. But it is still possible if I carefully draw my graph with a wide enough range for the x-axis so that I can see with my red line that the value of y when x equals 133 is 2. And the function is decreasing between x equals 148 and x equals 149. But when I draw the graph this way, it takes a long time, and I'm thinking there has to be a better way. Well, there is a better way, and that is going to be the subject of the next video. This is the periodic function, today's Daily Dose of Math. Please like, subscribe, and share.